Okay, so I'm assuming most of you are here to either learn bioinformatics or try to do some bioinformatics on your own. Some of you may have done some of it already, but it's always nice to learn a little bit extra. Okay, so let's get started. Talk a little bit about the course structure, what you're getting into, what you've signed up for. We're going to have 14 lectures and 12 practical sessions over the next 13 weeks. And I say tentatively because don't hold me to it. Sometimes it could be 15, sometimes it could be 13. But somewhere around that ballpark in terms of weeks, all right? Because the last class should be first or second week of May based on this calculations. It could, again, like I said, depending on if there's a snowstorm, if there are other circumstances, we may have to extend it. We also, depending on how many people are not able to attend the classes during the spring break or the winter break for kids, if you have kids, then we have to work something around that as well. All right. So the main purpose of this course is to teach you guys informatics. We keep the class size small, therefore we try to work with your schedule. Right. That's one of the primary things. The only thing that stays fixed is that we do have classes Tuesdays and Wednesday 2 to 4. Right. Great. So you may receive a letter grade at the end of the course. It's a may because most people have not opted for it. So far, I have taught over 100 students and 2 have taken it for a letter grade. If you are one of the third people to take this for a letter grade, then this is your breakdown. There will be 6 homework assignments, which account for 25% of your grade. There's going to be a final exam, that's 30% of the grade. And then there's data analysis for any given ChIP-seq or RNA-seq dataset project, and a demo. This is 40% of your grade. Again, this is optional, but if you're taking it for credit or if you want like a grade, then you have to do this. And for this, you may form a team of 2 people, although that is not required. Okay. Any questions so far? No? So this just proves that nobody is paying attention, or that you guys just don't have good math skills. Because if you add the numbers up, it falls 5% short. And that, I was hoping one of you would ask, if you didn't. So 5% of your grade, what is that for, the remaining 5%? Well, that's for the following activity. Regardless of whether you're taking it for credit or for not, you need to email me 1 or more things that you did not understand in class every single time. So every time you come for class, just email me stuff that you don't understand. Now, why do I say that? Of course, you can ask questions in class, but sometimes when you send an email to me, personally, I will be able to help you if you're not feeling comfortable asking those same questions in class. Okay? And it helps me improve this course further. Okay, so, and just in case you need it, video for each lecture will be available for at least the duration of the course. Sometimes you might find that the video is from the last semester because the content was either better, I taught it better, because I could be having a bad day or something and I might not be able to give it my best. But that way, you always get the best video posted. Also, it could be there's a couple of days delay between the taking of the video and posting it, just based on time schedules. So if you go on this website and you recognize that the video is from the previous semester, you can wait a couple of days and you'll get the new one, or that might be the best video for it. In any case, I'll make sure that whatever concepts are covered stay the same. All right, so if you watch that video, you should be able to come to the next class prepared for what's going to happen that day. Does that make sense? Okay. So Wednesdays, these are some Wednesdays are optional. I would say most Wednesdays are highly recommended. I'll tell you when they're not optional. For example, Wednesday, February 13th, Dr. Ting is going to be giving the lecture on sequencing technologies, so that one is not optional. That one's mandatory, so everybody has to attend that. Other than that, we do go over some of the same stuff that we did on Tuesdays, also on Wednesdays. So if you have something very pressing, feel free to skip Wednesdays, but let me know that you're planning to skip, or just try to attend in any case. It's always better. Oh, did I miss something? Yeah, so, and also all your work on this class will be put in your ERS1 server in your home directory. So what is your home directory? So yes?
There's somebody who just emailed and said he's stuck downstairs.
Oh, okay.
And wants someone to go get him.
Okay.
I can go.
Yeah, I can go get him.
How do we find the lecture and PowerPoints on the website?
So if you log in, then if you go all the way down, once you logged in. No, so your user ID is not your full email, it's just your yeah, there you go. And the password I emailed you yesterday.
And I changed it.
And you changed it, so once you log in with your user ID and password, I will go over it in the practicals, so if you have any issues then we can resolve it, but definitely try to log into the website. Most of you should have your passwords for this website by now, and if you try to log in, it should let you log in which case you should be able to see your course, and you should be able to see today's lecture there. Today's lecture and material. If you're not, we can resolve that. Right, so apart from Wednesdays, which are technically tutoring and office hours, because we go over stuff that we've already covered, I would recommend that if you would like, and again, this is optional but very beneficial, you can schedule one-on-one tutoring for your project or for other consulting that you might need, right? And finally, all the work will be put in this directory which is on the ERS1 server, right? So all of this just means that you need to have an account on the cluster if you don't have one already. So if you have one, then great, then you're already ahead, okay? If not, then make sure you do, and then that's where we'll be working. Alright, so this is the part where I'd like to put a disclaimer on this course, which is that if you do not work hard in this course, you're not going to learn much. In the sense that you will still be able to get a few basic concepts, but you will realize that this course does require some effort on your part, so I'm hoping that you're going to put in that effort. I personally make it my priority that every single one of you gets the time and the attention from me. But you need to take that initiative on your part and work on this, alright? So, how do you work hard? Well, basically one of the things is if you participate in class discussions, when I say, did you get it? That's your opportunity to say, no, I didn't get it. Hey, how come you got stuck?
I don't know. They're like really...
Didn't work?
No, they're very militant about not
Really?
letting me work.
Yeah. Okay. So then the other thing is there might be some required reading at home. Not much, usually very little. Most of the work that you have to do at home is just basically the stuff that you learn in class. Go home and practice that. So without practicing that at home, you might find that you're not up to date, because you'll find things that are easier in class, but when you go home, there'll be other issues that will arise, and that's when you truly learn, right? So definitely do some of those things, and then also just approach me, just be in touch with me. If you don't want to ask me in class, email me or set up a time. And then, as I said, please try to attend all lectures and practical sessions in person. I understand if you have a busy schedule and you have to fly somewhere or you're not here, that's okay. 1 or 2 sessions is fine, but just make sure that you attend most of these sessions in person. Alright, so with that, let's begin our lecture for today. Today we're going to be talking about Unix commands. Anybody know of Unix already? Okay. Yeah? Okay, good. Do you guys think you have a Unix on your computers right now? Anyone? So, everyone who's having a Mac, raise your hand. You have Unix on your computer. So Mac was built on a Unix operating system. So Unix is a very primitive OS. So what that means is that Mac basically took a free operating system. Steve Jobs took this free operating system, built a pretty GUI around it, hired some programmers, built like a nice little graphical interface, and then sold it to you guys as the Mac OS, which is actually a free operating system that was available all the way from the 70s. Okay, so let's talk a little bit about with that piece of trivia, let's talk a little bit about today's class, what the goal is. So I want you to focus on the big picture. Don't get caught up on the small commands in Unix right now. So while you will be learning about more of these Unix commands in the entire week, for today, just focus on learning what the big picture is, understanding what is a command, understand what servers and clients are and how you can use them for your work. In every class that you attend in this course, always keep asking, how is that relevant to me for my analysis? And that's the reason why we created this course, is so that everything here is relevant to your analysis in your course. Take small bites of Unix. I always find that fun. Okay. All right. Well then, let's get started. So, who here can tell me what is a server? Anyone? Right. How about what's a client? Well, the second definition is actually easier than the first. So a client is something that interacts with the server, right? So a server is essentially a machine. It's basically any computer. Any computer can at a given point act as both a server or a client. So for example, your MacBook right now, it has the capability, or even your Windows machine has the capability to act as a server, which means that it receives requests and provides them with a possible answer. And at the same time, your Mac or your Windows machine can also act as a client, which means that it can send a request to another machine and get output from that machine. All right? So a server is essentially a software. It's a software that is when loaded onto a computer, makes it be able to receive requests of a particular kind. Okay, so here's an example. When you open your browser, you type the address for a website, right? And you notice sometimes it translates to these bunch of numbers like 192.something, right? So that actually is the real address of that website, right? The name is just an alias that is created for you to make it easier for you to access that website. Now, what happens is when you type that name points or sends a request from your browser, which is a client in this moment, to a remote machine. Now, I don't know the location of that machine, but somewhere over the internet that request is sent, and on the remote location there is another machine which then sees this request from you and sends you back the web page and the content that is then displayed on your browser. Does that make sense? Right? So essentially, when you type www.google.com, you're contacting this Google's server or a machine, kind of like this machine, or it could be a laptop, or any other machine. But basically, it's a machine like, say, this one, which contains a software which will then receive your request over the internet and send you back a web page. So it sends you the Google's web page back as data, as HTML.
Oh.
So that's what is happening when you're typing google.com. Send request, data comes back, and so that machine has a hard drive, just like any other computer. It stores all the web pages for that website, and then it sends you back. Similarly, advanced searches, when you go to NCBI and you search, then the NCBI has, for example, it has a huge hard drive, which has a huge storage of data, and it sends you your paper and your request and everything back. So in that case, that machine is acting as a server, the one that is taking your request. And your machine is acting as a client, it's sending the request. Both the client and the server need something called as a network to exist, right? Unless your machine is connected directly to the server through a wire, there has to be a group of computers that are going to transfer your request onto the third party. Is that clear? So that group of machines is called a network of computers. These are also computers. It contains a router maybe. You have a network at your home. If you have a router in your house, then you're using a network already. All your phone is a computer, your Mac is a computer, or your whatever you have. They're all computers interacting on a network. Does that make sense? Okay. Cluster. Now, certain networks are created with the specific aim of doing analyses. These are called clusters. Cluster is also a network, but it has a specific purpose. For example, Partners has a cluster of computers that is used to run bioinformatics analysis or advanced computation, all these things. Again, these are just machines, kind of like again, I bring it to your laptop because that's basically what it is. In a way, if you connect all of these laptops together today with a wire in some way that they can exchange information, then it becomes a cluster. Does that make sense? Okay. So, what is MGH's cluster called?
RS1.
Yes, good answer. So, RS1 cluster, where everybody now has an account, hopefully, is MGH's cluster. So that's just the name of this cluster. And a cluster is a lot more than this. I mean, obviously, I've just simplified these definitions for you. There's a lot more to it. This is pretty much what you need to know in terms of the big picture, and then as we go further, we'll know more. Okay, so what is Unix? So Unix is an operating system. Do people understand what is an operating system? Somewhat? No? Well, so when you have your Windows machine, right? When you turn on the power, it does a bunch of stuff and then it loads up Windows, right? And then Windows helps you work with all these other things. It helps you transfer files, it helps you run programs. So Windows is your operating system. It helps you operate your computer. Same way with Mac. Mac has Maverick or whatever. They keep coming up with these newer versions, but essentially it has the Mac OS. All right? So Unix is a primitive operating system which pretty much does the same things like any other operating system. The only thing is that Unix does not have this graphics in it. It doesn't have these beautiful windows, it doesn't have a Finder, it doesn't have an Explorer. You have to write commands in this really boring black window or white window, and you have to manually type out commands and tell it what to do. Now, while it is boring, it does give you a lot more power. You have a lot more control on your computer, on its resources, on its memory. So that's why it still is in existence, because of that. And one other thing that you can do with Windows is that you can actually log into another computer with your Unix, is that you can log in from your computer to another computer and then work on that computer as if you are actually in that machine. So that is the reason why Unix is still in existence, which is why we use it. We use it primarily to connect from our client to a server and perform functions as if we are moving files, creating files on the server, but it looks like as if we're doing it in our machine. So that is why Unix still exists. So as I said, it provides a number of facilities, management of hardware, it has directories, and it has files just like you have in your normal computers, and it helps with loading and running of programs. So just like you have programs in any other software. Okay, so why do we use Unix? Well, number one reason why people use Unix is because it's free. It's in the public domain. Anybody can download it, install it on a basic piece of hardware, and create a computer. I think that's really powerful. So you can basically take your 10-year-old laptop that Apple has stopped supporting, or Windows has stopped supporting, install a free version of Unix, and you have a brand new computer. So that's why people still use it. You can have multiple users connect on the same computer. So, for example, the RS1 cluster, which runs a form of Unix, supports so many different users, and all of them could be logged in at the same time, and it does not have any issues with that. So it allows that. It's able to give different permissions to different users, create demarcations so that there's no overlap, and all of that is done seamlessly. So that's why Unix is important. There's lots of software, which we'll see when we go through this program, or this course. You'll see a list of programs that are used for alignment, for reads, of doing quality controls. All of these are free programs that are built on Unix operating system that we can now use, which makes bioinformatics very easy for us. And it does have some graphics as well, and it has a huge community. Okay. So, basics of Unix starts with you getting your own account. So when I said fill out this form, when you filled it out and sent it to the RS1 people, they created an account for you, right? That account is your space. It's basically Everything in that account you are responsible for, as well as you have all the power to do whatever you want in that space. You can't do something to another person's account. You can't delete stuff off of another person's account. You can't delete the stuff off of some common areas where you're not supposed to be. So Unix handles that with something called as permissions, and we'll understand permissions in a bit. Okay, so you type in your login ID and password to enter your account. We'll do that in a bit. So we'll be able to type in some commands. It'll open up a window where it'll say login, and you'll enter your login ID, you'll enter your passwords, and you'll be inside another machine, right? And you'll have then access to what is your space on that machine. All right, yeah, and then only if your login ID and passwords match will you be let in. Another thing which is funny is that unlike in other operating systems where you get dots or asterisks, Unix doesn't give you any dots and asterisks when you're typing out your password, so it's still being typed out. Do you understand what I'm saying? So you know how when you're typing in a box, you have a box and it says asterisk, asterisk, or dot, dot, dot when you're typing your password? And so Unix doesn't do that, in the sense that you'll still be typing, but there is no dots, it just appears blank. So a lot of times people will be like, whoa, nothing's happening, but it's actually registering your commands, right? Just remember that. So let's say there's your ID, and then you enter password, and you press whatever your password, type it out, and you press enter or return. As I said, the password does not appear. And then you get to this prompt called as the $ prompt or the Unix prompt. And now you're ready on another machine to run stuff, to run programs, to run commands, to do a lot of things. Okay, so let's assume for now that you've done everything, and then you want to exit this. So in order to exit, you can type logout, press enter, close the window. You can also type Control-D, or you can just type exit and press enter. Control-D meaning press the Control key and the letter D on your keyboard together. Okay? Does that make sense? All right. I'm going to pause for a second. So far, any questions? No questions? Come on. Nothing? You guys are really smart. We got a really good batch of students this time. All right. Okay, so the first thing I like to teach about operating systems is how to get help. And in Unix, when you've opened a window, if you type man, which is a short form for manual, along with the name of the command you want to find help for, it gives you an entire page about that command that you're looking for, right? So let's say the command for listing a directory, let's say the command to find out what are the files in your current directory you're in is ls. It's one of the most used commands is ls. So if you were to type man followed by the letters ls, it'll give you an entire page of what the command is, what are the options, what can it do for you, and examples. All right. So this is a good command to know, man. It also has apropos, which supposing you are looking for some topic which could be more generic, let's say game, help. Apropos helps you find stuff regarding that particular topic. So if you don't remember, for example, if you forget what is the command to find help, then you can just type apropos help, and it'll show you that man is a command to find help about help. See what I mean? Okay. Okay, so for most of you, these books are irrelevant. If you really want to go into Unix, these are some really awesome and great classics that people have written, and these books have been recognized as one of the best books in Unix. So these are definitely not recommended for this course, but if you wanted to go outside and study more and figure more out, then these will be the books to go to if you wanted to. For this course, I've actually put up a tutorial on the website, and there's a cheat sheet and a list of commands that I'd like everybody to go through during the week. So they're already on the website. I'll show you once we get to the practical session, okay? Which will also be the homework. All right. So let's try to understand a bit about how the Unix operating system is set up. All right? So, everybody understands the difference between hardware and software? Anybody want me to elaborate what's hardware, what's software? Yes, no? No? I'll do it anyways. So, hardware is your computer. In the sense, anything that is physical and you can touch with your hands, it's hardware. Software, on the other hand, it's more the part of the computer that you cannot touch. For example, a program, an operating system, it's a software. You cannot open your computer and if I told you, open your computer and find me the Mac OS, or find me iTunes in your computer, can I touch it? No, I can't. It's a software, it's a program. But hardware, on the other hand, I could, in fact, and I have opened my own MacBook and held my hard drive in my hand. I've had my bezel, the screen, all the components, RAM, everything you can hold in your hands. All of these are hardware. Now, here are some interesting things that I'm going to talk about now. So hardware, let's say we denote it as this inner circle because, well, it is all the way inside your computer. And then outside of that is something called as a kernel. So these are all layers. So this is the only part which is actually tangible. Everything outside of it is software and you can't touch it, but they do form layers. Right? So this is the physical layer, the inside part, which is the hardware. Everything around is all the software layers with different levels of security specific to the Unix operating system. So if you had a computer which had Unix installed on it, then this is how it looks. So you have your hardware. Unix creates a kernel layer around it, which is inaccessible to the user, which is on the extreme outside. So you're the user, and this is the kernel. There's no way for you to access the kernel other than going through the shell and through some Unix commands. All right. So as a Unix user, you will have to go through something called as a shell, which we will look at today and work in today. We'll open a shell window, and I'll show you what it looks like. And the layer of shell, you have specific Unix commands that will give you access to the kernel, which can also then act on your behalf on the hardware. But based on your permissions, based on the commands that you enter, the kernel decides whether you will have access to hardware or not. Right? So for example, if I was a system administrator, as a user who is a sysadmin or a super user, as sometimes people call it, he can enter commands that can actually shut down this hardware completely or reboot a computer. But you, as a user on Iris1, even if you try and enter those commands, it won't do anything to the hardware. It won't shut it down. It won't perform some advanced tasks. And that's why the Unix command system, because of all these layers and checks in place between the user and the hardware, is very secure. So you can type whatever you want, you can load whatever programs you want, but if you don't have the permission, you can type it in the shell, but this layer and this layer will always protect the hardware from the user, right? So that's why Unix is a very secure system. And this is the reason why we have it on our cluster. It acts as a huge barrier against hacking, against preventing, data theft and all the other things that you keep hearing about. All right, and as well as the protection for the hardware, so nobody can just log in from the outside and shut down your cluster, right? Because that would be a huge loss, right? Think about it. Let's say you're Google, and some outsider is able to come into this. When you say hack in, they can get to maximum to this layer. But then to go further to this layer, they have to have the permissions, and even then, they won't be able to shut down the kernel. Through the kernel will stop any sort of access to the hardware. Okay. So all your data and databases are stored in this layer, which is accessible from the shell with permissions. So that's why when you say a hack happened, most of the stuff that is hacked is this database. The hardware always is still protected. Cool? Okay.
I have a question about data. So data requires hardware to be stored. So the data is stored on a hard drive, but is the hardware of the cluster separate from the hard drive that's storing the data?
So in fact, multiple hard drives can be made to appear as one on So because the hardware, so here it looks like one blob, but essentially it's split into multiple terabytes and terabytes of hard drives, and this layer actually makes it look like it's one hard drive, but essentially it's split up. So, sorry, what was your question?
So if databases are outside of the
Yeah,
kernel,
they are.
then
So database is a software again. Database is a software,
yeah,
but data itself would be stored as bytes on this
Hardware.
on the hard drive.
yeah.
But the database is just a software, and there is a software package or a program that then goes and looks at those bytes and creates, like relationships in that. That's why they're called relational databases. You're literally just going and saying that, okay, name is stored here as these 10 bytes. I'm going to add this name as a table, as part of a table, which, may or may not exist. It just is a relational entity that is created. Does that make sense? Okay. All right. So the shell. So this is the topmost layer of the operating system. This is what you use to interact and work with as a user. So the shell has one job, and basically it runs it in this particular phase, cyclical process. So it displays a command prompt. So this is where your dollar prompt is. This is where you start. Then if you enter a command, it reads that command, and what it does is it processes the command and executes that command. Once everything is done, it comes back to displaying the command prompt. All right? So we'll see this today. So basically this is what a shell does. All right, so here are some commands. For example, I wanted to say date. If you wanted to see date, what's today's date? You just type this date, and it shows you. It can show you calendar 3/2016. So what was the month of March in the year 2016? How does it look like? Who tells you who you are as a user, not as a person. As a user, it tells you who you are identified on the network as. What's your alias? ls is a listing command. It tells you the list of all the directories that are there. And I'll show you how we'll go through all of these commands in the practical, and we'll also see what a shell looks like. These are the names of the commands, and once we enter this, it does these, things that these commands are supposed to do. We'll see them. Alright, so here's a command to change your password. Now a lot of times we, as users, might not be able to do it in ERIS-1, but if you have your own Mac or Windows or your own Linux, then you can just type the password command, and it's pretty similar to changing your password online. It asks you for an old password, and then it asks you for a new password, and then it changes it. If you forget your password, there's nothing you can do. So, so when you change it, just be very careful. Okay, so it'll ask you for a new password twice, so make sure you enter it properly. Don't enter the wrong password twice, because it'll lock you out of your system. I mean, this is for if you have your own Linux machine. If you do it on your partner's cluster account, that's fine, they can reset it for you. Do you know what I mean? Okay. Okay, so these are some date commands. Again, just gives the date and time, gives the calendar. Not related to your bioinformatics stuff, but uptime for your system, host name, what is the name of your machine on the network, who am I, what is your name on the machine, on the network, calculators to do simple calculations, like for example, you can do EXPR followed by this and it'll give you the answer, 15. BC gives you a programmable calculator. So all of these are done in that black shell window, which we will open, all right? We'll see. Okay, and then there are some more commands over here. As I said, for the homework, there is a document that I've uploaded which contains the commands and what they do, and I want you to practice that. We'll practice some of those in our session, practical session. All right. Okay, so before I get to redirect and all these other things, so why are we learning these commands? Why are we learning these commands?
Because it'll be useful to us.
How?
In general.
Huh?
They're in general useful.
So, as I said earlier, anytime I'm teaching something, you have to ask yourself and me this question: how is this useful to us? So, Somebody asked me that question.
Why are we learning these commands?
There you go. You're learning these commands because the data that you will get from the sequencer will be stored on your Linux machine or a Unix machine. Now, in order to, let's say, see what files were sequenced, just the name of those files, you will have to use the command called ls, this one, which will show you the names of those commands. For example, if you want to look inside a file and see what the contents are, you can just use cat and it will display the contents of that file on your screen. So, and then if you want to move that, move the file from one place to another or copy it, there's another command for that called cp. And you need to transfer a file from one directory to another, that's another command for you. So that's why we're learning all these commands and that's why we're learning Unix. In order to get full control of your data, you will need to understand Unix and basics so that you can really know what your data looks like, right? Does that make sense? Okay. All right, so here's something that I found important, which is redirection, pipes, and processes. So let's talk a little bit about redirection first. So remember I said ls. So ls is a command that lists out your directory. If you type a greater than sign in front of it and then you type dir.txt, it basically, instead of giving the output on your screen, it gives the output and stores it into this file called dir.txt. So all it means is that now when you type ls, it doesn't show you everything on your screen, it just transfers everything into this file. Same thing for calendar. If you want a file called year 2004, it'll basically transfer everything into this file called year 2004. Okay. Before I proceed, do people understand what files are? Do you guys understand what files are? Everybody? No? You need to speak up, guys. I mean, do you understand what files are? Do you guys in the back? Yeah? Okay. Otherwise, I have no way. So either nod or say no. Yes or no are good indicators whether you're following or not. So, if you know what files are, then basically this is what it does is it's almost like this opens your. Think of this as a Word file, and then it just opens that file just with this one line, one character. It opens this, stores everything in it, and closes and saves it. All right. So that's just this one thing. See how much time you save? You don't have to open a file, you don't have to copy, you don't have to save. It just does everything in just this one symbol. Alright? Okay, same thing for calendar. Sometimes you can have two of these signs together. So two of these these redirect operations. What that means is that supposing you created a file called years, and you have a calendar already existing in there, then if you type another calendar, it just adds on to it. So adds a new page as opposed to deleting and overwriting the previous page. Yes.
So do you have to add file extensions into that? Like in the first line there, you have a txt, and then
so that's optional.
Okay. So is there like a default type? What's the default?
No, there is actually no default type. So basically, it stores everything as text. Unless it's a different, so sometimes you'll find, we'll come to it later, there are binary files. So we'll use some binary files and I'll show you them, but most of the times these are just text files. So even if it doesn't say .txt, it's still text. And that's the beauty, that you can take any file and you can look into it as if it's a text file. Yes?
So does it have to be consistent? Like if you use the .txt and then later you try to append to the same file and you don't put the .txt, will it do?
It'll create a new one.
Okay.
So if you don't put let's say you added cal 2004 in year 2004.txt, and then you said cal 2005, and then you just said year 2004, then it creates a new file.
So that's just the name.
That's just the name. So it's very sensitive, also case sensitive. So if you had a capital Y versus small y, it's going to create a new file. These are separate. Same with extensions. So if you just put tx and forget the t, then that's a new file. So everything is case sensitive. Okay. There are also something called as pipe. So where the output of one command is passed on as input to the second command. So for example, the sort command basically alphabetically sorts your list of text. right? So if you were to do, and the ls command, as I said, ls gives you your listing in your directory. So everything in your directory, all the list of the files, their names are printed out. So if you wanted to take the output from ls and pass it on to sort, it'll take everything in your directory and sort it alphabetically and then give you the output that way. So this way, in this way, you can combine, using this pipe symbol, you can combine multiple commands and get outputs like that. Does that make sense? Yeah? Okay. We're going to skip processes. This is probably not useful to us. Okay, Unix file system. So I've been talking a lot about files. I've been talking a lot about, listing files, this files, and frankly, we will be dealing with a lot of files because that's where our data is. All our FASTQ files, which contain our reads, BAM files, which contain alignments, they're all files. So let's talk a little bit about what are files and how are files organized in the Unix operating system. So there's ordinary files, there's directory files, and device files. How are they different? Well, anybody know if I just say what is the difference between ordinary and directory files? No? Okay, good. So ordinary files are basically your Word documents, stuff that you create, right? It could be a FASTQ file, which is a read file. It could be your alignment file. It could be your reference genome file. They're all ordinary files. Directories or folders, so if you're in Windows or a Mac, you know how you create folders, right? Those folders are actually considered files or directories. So these are called directory files. So directory files contain ordinary files, right? Does that make sense? And finally, there are device files. Device files, so in Unix, it's very funny. They actually consider even your hard drive as a file. Even if you attach an external hard drive, it considers that external hard drive, which is a device, as a file. So this makes it very easy to navigate between one, you can copy an entire device from one location to another because it's treated as any other file. The same commands that work for ordinary files will work for the others most of the times. All right, so here's an example of a simplified directory file system or tree. It's a directory tree. So at the very top of the directory is this /. This is called the root, right? So this is a root. It's just one /. That's the name of the topmost directory. It's root. Within the topmost directory, there are multiple directories like etc, or bin directory, or user directory, or dev directory, or temp directory. In our case, there is this directory in root called phs home. Once we log in, we'll see that it's called phs home. Now, usually, each of these directories are files. So bin is technically it's a directory, but it's also a file. Each of these files contain specific other files. For example, the bin directory under the root directory usually contains program files. So your commands like date, calendar, ls, all these other programs are also files which are contained in the bin directory. And you, if you're a super user, can go in there and delete the, say, date file, and then nobody would be able to use date command. Does that make sense? But you're not a super user, so you won't be able to do it. Okay, so within your normal, you have your user directory. Let's say there's a folder for faculty. Within faculty, this guy, Michael Jackson, is a faculty, so he has his folder. So what I'm trying to say is that it's all very much like a tree structure with the root at the top, and everything else follows depending on what group you are in. So all users are under user. In our case, the user directory is called phs home, and within that, there's no faculty, or we just have straight away phs home followed by your user ID. So mine, for example, is vt094. So phs home /vt094, and under that, I can create my own directory structure. I can create my own folders. I can put my own files in there. But some of these are common for everybody. For example, we do have a temp directory under root /tmp, and for the portion of this course, for a big portion of this course, we'll be storing most of our files and folders in the temp directory. And it's also useful to transfer stuff between one user and another, because everybody has access to the temp directory. So supposing you want to transfer your data, then you can just put it in temp, make a new folder, and then tell the other person, hey, I've put it in temp, you can take it from temp. Does that make sense? So, so here are some of the FAQs that I've received over the years. So I probably answered the first one. Is that clear? Why is Unix so important for bioinformatics? If not, I can explain again. Do you guys understand that? Why is Unix so important? Most of your data will be stored on a server which runs Unix. So if you want access to your data, you need to understand Unix. There's no way around it. What is the difference between network and clusters, and how do you establish a network? Is that clear? What is the difference between network and a cluster? Who can answer?
Cluster is a type of network.
Correct. But every network is not a cluster. Cluster is a specific kind of network which is used usually for high-end computation. How to use pipelines on ERS-1 cluster? So this, I guess, will come over later. But you can make pipelines on ERS-1. For example, at the end of the course, I hand you over my pipeline for running your RNA-seq analysis. And then you can use that to basically run hundreds and thousands of samples within a few hours. Right? And a pipeline is basically a collection of programs that a bioinformatician or someone who has written puts together and makes it easy to do a step-by-step analysis for you. And how to use that we'll cover during the course. Like we'll cover individual sections of the pipeline, and then in the end, you'll get the pipeline. Okay? We define a cluster as multiple nodes and computers connected. Can there be nodes that are not computers? So so these are all questions that people have asked me in the past. I don't know if you can tell. So, can there be nodes that are not computers on a cluster? So that is actually not likely. Most of these are going to be computers. There could be nodes on a network that are not computers. Can anybody tell me what those nodes might be? On a network, not on a cluster. A phone. Your phone can be connected to a network. Like right now, I'm connected to PHS Wi-Fi 3, so I'm on the partner's network. So my phone is a node, technically, on the partner's network, but it's not well, actually, it is a computer. If you really think about it, your phone is a computer.
A light switch?
Huh?
Like an automatic light switch?
Yeah, so it is a computer.
No, but not a computer.
Yeah. Right. If I want to use this, so I'm going to basically skip most of these. If you have any questions, let me know. I think these are more for later. I can go over it next time. All right. So as I said, this is a root directory, just a /, right, followed by /bin, which contains all your commands. /etc folder or directory contains your system data files. For example, all your passwords are stored in that file. /dev contains files representing all your I/O devices, so input/output devices. That's like, there used to be CD-ROMs and stuff connected to so those were in this device directory. Pathnames. So this is an interesting concept. What time is it? Just to keep track of time. So pathname is a sequence of directory names separated by these /, which identifies the location of a directory. All right. So here's an example. So I'll show an example, but there are two sorts of path names. There's the absolute and the relative. And so this is what it looks like. For example, this is a path, right? /bin is the path to the bin directory from the root, right? /etc/terminfo is the path to the terminfo file or directory from the root, right? So as you keep adding stuff, so if I was to ask you what is the path for the add directory, that would be export user home add. Right, so these are all the directories that are connected from root to this, that connect the root to this directory. That is the path. Does that make sense? Yeah? Okay. Okay. So, when we write down everything starting from the root to that location, it's called an absolute path. Because you're connecting from the root to the directory, it's absolute, right? So then that makes me think of what is relative path. So relative path is the sequence of directory names below the directory where you are now to the directory of interest. So let's say you are in this S391020, right? 120. So let's say you're in this directory. So if you're in this directory, then relative to this directory, the path to PROJ1 is your relative path. Does that make sense? So you don't have to include the slash all the way from slash. You can just say, oh yeah, relative to my location, the path for PROJ1 is just PROJ1 if you're in that directory. If you're in home, which is a previous directory, then the path to proj1 is this directory and then this directory. If you're in user directory, then the path to proj1 is from home to this to this. Does that make sense? It's relative to where you are in your directory, and to the path means the path to the directory of interest where you want to go or where you want to see. Okay. So whenever you use a command in Unix, most of the time if you're trying to access a file or a directory, you have to give the full path to that directory. Or you need to find a way to specify clearly what is the directory or what is the file that I'm trying to access. And that path has to make sense. For example, if I want to access the password file and I want to list it, I can say cat, which is the command to list the contents of a file, and I give it the absolute path from root, go to etc, and then go to password. Does that make sense? But supposing I was in the etc directory, I was already in that directory, then I could have just said cat password. I didn't need to type all this, the etc part. All right? Does that make sense? Because you can now reference the password file because you're already in this directory, then you don't need to type the whole absolute path. Although, in the interest of safety, I always recommend when you're starting out in Unix, just type out the absolute path. Because then you don't get confused. All right? All right. So here's an example of moving between directories. So this is the directory you're in, and then these are some other files and directories that exist. So supposing if you're in directory this S239, so if you're in this directory F33910.120, then how do you move to directory project1, right? So let's go back and look. So we're in this directory. How do we move to this directory? If I told you the command to change your directory is cd, cd stands for change directory. How would you change your directory from here to here? Any guess?
CD-PROJ1.
Okay, so that's a good attempt, but honestly you don't need the dash. You can just say PROJ1. In fact, if you put a dash, then you're saying go to the root directory and then find a directory proj1 in root, which doesn't exist. So you will just say cd space the name of the directory because you're already here. Or you want to go from here to here. All right? Okay. So now that you've done that, you are now in project1 directory. This is what is called as the current working directory. Now your current working directory is PROJ1, project 1. Okay, so how do you know where you are? Well, you type the command pwd, or present working directory, and it tells you which directory you're in, and this is very useful, because a lot of times in Unix you'll forget where you are. Sometimes when you have 10, 12 folders, you're in the 10th one, and you're like, oh, where am I? How do I get from this folder? And then, supposing you wanted to move back one level, all you have to do is type cd, and then type space, and then these two period signs, dot, dot. CD space dot dot brings you one level up. Dot dot is a shortcut for saying one level back. Okay? All right, next. Supposing you're in project 1 and you want to go to project 2, well, obviously project 1 and project 2 are at the same level. So you have to go one level up in order to then go back to project 2. So I don't know if you guys remember, but this is our tree. We are now in project 1. There's no way to go directly to project 2. We have to go one level up and then go here. So therefore, in order to do that, we do cd space dot dot / project 2.
What dot dot? I thought just one dot.
No, there's 2. 2 dots means go one level back. 1 dot is actually a shortcut for current directory. So far so good. So now dot dot / project 2 therefore is a relative path name because it's relative to where you are. Does that make sense? Okay. All right. So here are some special shortcuts or path names. So this / is root. If you say cd / it just brings you to the root directory. If you say cd dot, it doesn't do anything because it's the current working directory. 2 dots means the previous directory, the one previous to your current directory. So here's also another shortcut, which is a tilde sign. So this, no matter where you are, brings you back to your home directory, or it's a shortcut for your home directory. And if you are anywhere and you just type cd, it also means cd tilde, means it also brings you back to your home directory.
What's
Yes.
the home directory?
Home directory is the directory which is the directory where when you create your account, you get that phs home / your user ID. So the directory where you log into first, when you log into a cluster or a server, you will be your home directory. Okay, so that'll in our case in partners, it's root / phs home / your ID. So like here, it's P capital S / in my case it's BT094. In your case it could be something else. Right? So that's your home directory. Okay? Alright. So we're almost done with these and then we'll quickly go to our practical. So here are some commands. You use cd, cat file I already told you, displays the contents. ls displays the directory or the contents of a directory. Making a directory is an important one. So mkdir, this is a command that helps you create a new directory wherever you are. Right? If you're in the right location and you have permissions, you will be able to create a directory with whatever name you choose. rmdir is a way to remove a directory. All right? There is no trash folder in Unix. Let that sink in. There's no trash, which means everything you delete with rmdir is non-recoverable. Ever. It's gone. You will not get it back. No sweat, tears, or anything will bring it back. So, use the remove command, especially when you type rmdir with caution. Let's say you sequence your data and it's in a folder. Always try to use the command move mv or cp, copy, if you want to take your folder from one location to another. And then, once you're 100% sure that the entire data has been moved, only then go and remove the directory. Otherwise, if you erroneously remove a directory which you have permissions to, but you shouldn't, then you could lose years of work. And people have lost years and years of work just by using this command. Permissions. So usually you have read, write, and execute. So they're denoted by the symbols R, W, and X. So for example, in this case, there are 3, so RWX here, RWX here, RWX here, possibilities. If you don't have a permission for something, and I'll explain what these are. So there's usually a group of 3, 1, 2, 3. And the first one is for the owner, which is you. So these specify the permissions for a file. The first one for the owner, meaning that as an owner, you have read and write permissions on this particular file or directory. Does that make sense? Then group. So most users are part of a group. So let's say your lab is a group. It's a group of individuals which the system administrator can create, and within a group, everybody can have certain permissions. And you as an owner can tell what the permissions are. If you own a file, you give the permissions for that file. So you can say, okay, I'm going to give read permissions to everybody in my group. And that's it. I don't want them to write to it. I don't want them to execute it. Nothing. Just read. And same thing for everyone who is not in your group. Right? So let's say this is another lab, another user on the server. It could be anybody. And you don't want that person to see this. You can even make this --, meaning you can change the permission so that it doesn't even have read permissions. Okay? So, and then in order to change the permissions, you can always do +W and -W and so on and so forth to create whatever combination you want for your read, write, and execute. And we'll do that in a bit, and I'll talk more. All right. These are some commands to work with files. So first thing is cat followed by file name. It displays the contents. Less is a good command. It just displays the few top, whatever, 20 or so lines in the file. Head again displays only the top few lines. Tail displays the bottom few lines of a file. So if you have a file that's 3 GB, this is a useful command because you want to know sometimes what is at the end of the file without having to open it. Copy, CP. Move just moves the file from one location to another. You can also rename it using move. RM is a remove command. It will remove the file, delete. WC gives the word count. So how many characters are there in this file? And grep is if you want to search for, grep is a search function in Unix. It helps you search for individual characters or file names within a file or a directory. Okay? So let's try some things now. We can finally open up and start to do some things. Let's take a quick 2-minute or 5-minute break, 3:05, 3:10. We start working on the practical.